Hello geometry people. So we want to take a look at intercepts and what they are. When you think of the word intercept, you can think of the word intersection. And it's sort of like the intersection of two streets. It's where they cross or go through each other. And so, again, think of it as intersection. It's where the line that you're graphing, or in this case, parabola, crosses through a particular axis. It crosses through either the x-axis, the x-intercept, or the y-axis. So as a reminder, the x-intercept goes left and right, like the x-axis, and the y-intercept goes vertically and it goes downward. That is our y-axis. So we're going to be looking for the x-intercept and y-intercepts of parabolas. Why is an x-intercept so valuable? Well, an x-intercept is our solution to your equation. It will give you the actual answer visually. So if you take the equation x squared minus 4 and solve it algebraically, we set it equal to 0. We add 4, and we get x squared is 4. We square root both sides, and we put the plus or minus, because 2 times 2 is 4. But 2 and 2 times negative 2 times negative 2 is also 4. So my two solutions are when x is 2 and when x is negative 2. And look at exactly what we have on the graph. The x-intercept is at 2 and negative 2. So these two spots where they cross through the x-axis are called the x-intercepts. This one's at 2, 0, and this one's at negative 2, 0. They often want them written as a point. Let's try another one. So if we were to do the same thing and solve the equation x squared minus 16 is 0, we would get x is 4 and x is negative 4 by square rooting 16 when we move it over. And exactly that's what we get here. So for the blue parabola, our x-intercept is 4, 0 and negative 4, 0. And again, those are solutions to our equation. And it's a visual way of finding your solution instantly if you have the graph already. So what is the y-intercept? Well, actually, one more thing. Does a parabola always have an x-intercept? And the answer is no. When we get into imaginary solutions or lateral solutions, then it might look something like this, where the parabola is shifted up, like the red one here. So in this case, our solutions will be 2i and negative 2i, which are what we call imaginary numbers, even though they're not imaginary. They used to call them lateral numbers because they're sort of above your graph. You could look up there's a great video, I think it's the first search result on YouTube, what are imaginary numbers, and the picture itself has a great idea of what imaginary numbers look like on the graph. Let's see if I could pull up a picture very quickly. So there it is. That's from that video. So lateral numbers have solutions, but the solutions are what we call imaginary numbers, and they don't show up on the x-axis. So what is a y-intercept? So the y-intercept is the same concept, but the y-intercept here is where it crosses the y-axis. So here is one of the y-intercepts for the red line. It's at 0, 4. So we need to be good at graphing a point or plotting a point. Here is the other one. The y-intercept is at 0, negative 4. And the third one down below, the y-intercept is at 0, negative 16. So a parabola won't always be facing this way, and it also won't always be going through, the vertex won't be always at where x is 0. So let's try another parabola and just explore that idea for one more second. And sorry, you're going to hear my neighbor's dog. So here is the equation now. This orange equation, it doesn't have an x-intercept. It only has a y-intercept. And this intercept is located right here, and it's at 0, 7. Oh, the graph actually shows it for you. So if I were to shift this downward, I will then have x-intercepts as well. And in this particular case, our x-intercepts are decimals, negative 3.7 and negative 0.26. And my y-intercept is the one touching the y-axis here. That one is located at, looks like 1, yeah, 0, 1. So those are the ideas of what x-intercepts and y-intercepts are. It could be any type of graph. So for example, I could graph a straight line, and I have an x-intercept right there. And I have a y-intercept right there. So hopefully that helps you understand the idea of how to find the x and y-intercept, and even a little bit about why they are important. They give us the solution. Our x-intercept gives us our solution to the equation we're solving visually on a graph. In a parabola, we can change the way it's facing and make it y minus, or x equals y minus 2 squared. And now it's facing a different direction. So let me hide this one. So now we can see our x-intercept is here at 4, 0. And our y-intercept here is at 0, 2. And our y-intercept, when it's a y-squared parabola, is going to be the solution for that parabola. So if I actually tried to solve it, I would say y minus 2 squared equals 0. And I would actually set one of them equal to 0 and get y equals 2. So the x and y-intercept can be handy to find a solution to an equation, and it will find the solution for your y value or the solution for your x value. Hopefully that helps you understand at least the basics of what an x-intercept and y-intercept are.